If you ever designed something for military avionics, you've probably heard of VITA before. And they have a wide variety of standards. And trying to move into the next generation is something called VITA 100. And I have a group of people here that'll be able to fill you in on all the details. So to start with, Dan, can you tell us what is VITA 100?
VITA 100 is essentially a revolutionary standard that is being built to address paradigm shifts in technology and capacity and capability today by doubling the pin density, increasing the speed, and increasing the power of what can be on a modular plug-in module.
Mark, why is the VITA 100 standard important?
I'm going to start by saying that VPX and OpenVPX have been a real workhorse for our industry. It's been just really our go-to platform when we want to create high-performance embedded computing systems, especially for streaming kinds of applications like sensor processing and things like that. But it's reaching its limits. It's been able to grow over time, but we're kind of reaching some physical performance limits that we just can't get more out of it. And so it's vital that we have a next generation go-to architecture that we can rely on and that we can continue to grow with. As Dan pointed out, the applications are increasingly hungry for especially I/O performance. The processors, especially when you start getting into like GPUs, are voracious in their processing of data that's incoming, and we need a platform that is rugged and high performance to keep up with that.
Yeah, there are. And really, there's a whole suite of VITA 100 standards that are being developed, different dot standards around all the aspects. So we're taking essentially OpenVPX and creating new open standards around VITA 100. And there's a system-based standard 100.0 and .1, which are the slot profiles. There's a whole host of mechanical standards to provide different module configurations for different cooling methods, including conduction, cooling, air flow through, and liquid flow through. System management, Dan's actively involved in leading that effort on system management under 100.20. The connector standards, 100.30 and 31, will define the connectors, and I can talk a little bit more about that. There's a power supply standard. There's a signal integrity standard to call out like reference channels and how it's going to be modeled. And then future is looking at test and development equipment. So there's a lot of activity in VITA by a lot of the industry leaders defining those standards, and they're very actively engaged right now.
And if I could, I'd want to add to what Mike just said. We have the benefit of drawing from the earlier VPX and OpenVPX standards, and we're actually going through and kind of picking the best features, the best way of approaching this new standard. So yeah, it's kind of the benefit of hindsight. It's going to be a much stronger and much tighter set of standards than OpenVPX was.
Can I add a little bit to that? So I agree totally with what Mike and Mark has said around the benefit of building the system architecture standard with the experience of the past 20 plus years of OpenVPX. But one thing too that we also need to look at is that when we set forth and established OpenVPX, we wanted it to be something that had longevity and something that was going to support a period of time. We knew that there would have to be evolutionary changes to it because we knew that we had at the start limitations into what we could do with the connector systems and what we could do with some of the other cooling mechanisms. And as you've seen, and as Mark had talked to earlier, there were so many evolutionary steps we could take with changing those connector systems to maintain plug and play ability and adding to the cooling type of mechanisms to the point that the standard could no longer be tweaked to support the next generation of technology. So as we go into VITA 100, it's going to be important to us to understand, how far do we want to stretch this? And even though we've learned a whole lot about system architecture that has really driven those evolutionary changes, we're into a new world with system on packages. We're into a new world with interconnect systems. And I think that we need to make sure that we think about how those are going to influence what we know today as modular or modularity at a physical plugin module level is probably going to be different as we move forward and we see consolidation of functions on a single physical module.
You were talking about, the evolution. What about things like the management support? It sounds like there are a lot of things that may have had ideas in existing VITA standards, but are essentially evolving to something much more sophisticated.
That's a great question. So when we initially established 46.11, which was system management for VPX, there was no OpenVPX at the time. And the intent was really to provide hardware-based management that aligned with commercial standard industry, which was bring IPMI infrastructure over to the hardware so that we could standardize how we communicate to learn the inventory in our systems, how we communicate to see environmental sensors like temperature and voltage. These are all common things that were being implemented by VPX suppliers, but VPX integrators would have to write custom software and custom interfaces to allow them to get the exact same information from every card. And as we started to build OpenVPX, we started to build that hierarchy that allowed us to see information at a chassis level, at a module level. We moved it into things like power supplies, and we moved it into more capabilities. And that was even extended further in SOSA and then brought back into updates of 46.11. Now, as we progress forward, what we really are looking to do with VITA 100.20 is move that management infrastructure over to a net-centric environment to allow us to manage distributed computing systems, both sort of hybrid cloud or just plain old distributed, in a manner that is much more consistent with what people realize today in how they have their interconnected components. So what it will allow us to do is it's going to allow us to do much larger sets of configuration, much more dynamicism, and it's going to allow us to bring security into the system that's much needed for what we're doing today.
But I could also add, I think just kind of stepping back, there's a lot of decisions and a lot of input and consolidation of requirements right now. But there was a study group 2 years ago that started within VITA, actually 2022, that ran for 2 years, just collecting information about what this next system is going to need to look like, what cooling methodologies we're going to maintain, how we're going to define the connector requirements, what form factors we're looking at. So from a connector guy, as a connector guy, and us developing connectors around it, we had a matrix of like 56 different requirements: mechanical, electrical, physical constraint, signal integrity that we had to follow, and that was based on a lot of industry input that's been very valuable. So we're really thinking it through on the front end, mapping it out. And like Dan and Mark have said, we're leveraging what we know and it works very well today, and we're evolving where we need to.
Well, speaking of today, what about the existing VITA standards? Mark, could you talk a little bit about, how these are going to coexist with VITA 100 and how a designer may be choosing from one versus the other?
Oh, sure. That's a great question. Because VPX isn't going to go away overnight. We're not going to suddenly shift and all of a sudden be a VITA 100 world. There's going to be, many years of OpenVPX based systems because it's still our workhorse. But experience has shown that we're likely to have hybrid systems for a time, where certain benefits from VITA 100 will be derived from products that people create, mixed with more legacy, if you will, OpenVPX-based hardware. And so those hybrid systems almost certainly are going to happen. And I know that people are actually thinking about that, not yet designing, but certainly planning for such an eventuality. So you'll have OpenVPX-based systems, you'll have hybrid systems as VITA 100 matures and products mature, and then VITA 100 pure systems, if you will, start to emerge.
Yeah, it sounds like that transition will be significantly easier than, say, going from VME and combining that with OpenVPX.
Exactly. Yeah. So not only are we planning for this, but we're making sure that we're compatible, that we're not introducing things that would hinder those kind of hybrid systems. And the fact that the interconnects are, I would say compatible is probably the best way to put it. That makes it a whole lot easier. The VME to VPX hybrid systems were a little challenging. Talk about a paradigm shift.
Mm-hmm. Okay.
And,
Well,
and just from an interconnect standpoint, so we do have a new connector. The digital copper connector addresses the needs that Dan talked about at the beginning, the need for more pin density, the need for generations, higher speed. And the connector addresses that. It meets the level requirements I talked about. So we're creating a new standard around that connector. But one thing we're leveraging that we did fairly well in OpenVPX and involved was the coax and optical integration in a module, looking at how we can pack as much density as we can, look at what those form factors and those interfaces are. So we're leveraging where we can reuse some of that within the same slots. So it's a good mix of taking the best of OpenVPX and then pulling in new technology.
okay. Well, speaking of the best, let's see about wrapping up. Dan, could you tell us what your favorite thing or most interesting thing you've seen thus far with the VITA 100?
For me so far, I think it's been the discussions about what the next generation system looks like. I think the group is far more focused on the system level than in the past, where in the original days of OpenVPX, there was a lot of focus on individual modules. But the idea that we're coming at it and really focused at that system integrated level from the start is easily the most exciting thing in my mind.
It kind of built off what Dan said too. It's the collaboration and the open, input from technology leaders and the balloting and working toward agreements on what those next solutions are. I think when we first started this process, we were trying to leverage as very much as we could from VITA 46 and shying away from maybe making a stronger change. But I think that's turned around a bit, and it's going to be exciting.
So want to kind of echo what Dan said about the system aspects of the standards. I am really excited about VITA 100.20 and some of the things that are being planned. I think it'll be kind of a quantum jump in capabilities that Dan has in mind in what he's mapping out. But I also want to throw in just a little kudos to the group for coming up or for proposing a new intermediate size board form factor. We've relied on 3U and 6U with VPX for a long time, but the new 4U actually opens up some avenues that were otherwise pretty limited or closed to us. Because it's a new form factor, we're not having to try to fit it into spaces where we previously put 3U or 6U in the past. But so we can do some things to dramatically improve the processing density and the power densities that we just can't do with 3U or 6U. So I'm really looking forward to what comes out of that work.
Well, very good. Well, thanks everybody for filling us in and introducing us to VITA 100. I'm sure we'll be talking about a lot of this in the future.